I'm Tristan Shepard, and our Strengths and Materials professor has assigned us the task of performing a lab that deals with a statically indeterminate load.
A few of our colleagues aren't here right now. We will meet up with them later and do the calculations to see whether the physical calculations match up with those that are computed in the back of the book. See if they are actually real to life.
So I will be manning the camera.
And I will be performing the experiment that you're about to see. So first is our setup. For our setup we have our T6061 T6 1 inch by 1 inch aluminum bar mounted to our table with two really large clamps. It is mounted to our workbench, which is for the most part unmovable. We're calling it our ground. We have our dial indicator hooked up to our load, where we're going to be hooking the loads up to, and it'll tell us our displacements or deflection so that we can compute it and gather the data that we need. So on the bar itself there is a small divot, or basically a center punch mark, that we can drop our hook in and it will locate the same point every time, so we get reliable readings, so we don't have a variation of where we put our load. Speaking of our loads, if the camera will point to the ground, we have 5 loads. The first one is a 15-pound weight. The second one is a 30-pound weight. The third one's going to be a 30-pound weight. The second one is a 24.2 pound weight. The fourth weight will be a combination of the 30 plus the 15-pound weight. And then for the final one, we have a 65-pound wood planer that we're going to use to hang off the edge of the bar. So first we're going to hook up our 15-pound weight. Make sure our dial indicator is zeroed, which it is. We have also measured the weight of the hook and the chain, and we'll add those to our calculations when we go to the final portion of that. So I'm going to gently set this on here without trying to disturb the measurement. Okay, and it's telling us we have a 0.08 inch displacement. So I'm going to write that down on our sheet. I'm going to carefully remove it. And our gauge has gone back to 0. So we have not passed the elastic region, and it has not been permanently deformed yet. Now we're going to move on to the 24.2 pound weight, which is called the motor. Again, gently set this on here as not to cause any false readings. Make sure we have it in the same place. Let that sit. Now we have a displacement of 134 thousandths of an inch, or 135 thousandths. I'm going to record that as well. Now, gently remove this. And let's see if we can. There. That's back to 0. So again, we still have not passed the elastic region, so we have not permanently deformed it yet. Now we're moving on to the 30-pound weight. Put it in the same spot. And now we have deformed or deflected 171 thousandths of an inch. Nope, 72, not 5. Okay, so now we're going to do our combined load of 45 pounds, which is a combination of our 30 pounds and our 15-pound weight. As soon as I get this unstuck. Make sure we get this secure so we don't drop this on anyone's toes, mainly mine. And here we go. Watch your fingers. And we got a problem. We have run out of indicator room. The interruption you saw there was due to an error in our setup. So our dial indicator actually ran out of travel, and after releasing the load, the bar did not, or the dial indicator itself did not return back to 0. So through that, we have come to a conclusion that either A, it got screwed up when we ran out of travel, or B, that we have made it permanently deformed. But we moved our setup down and we re-zeroed it, and we're going to re-put the load on and continue from there. And then later on when we do our calculations, we can figure out if we actually did cross the deformation stage into permanent deformation. So we're going to continue on with our setup as normal, and we will find out later if we screwed up. So re-putting on the 45 pounds of weight. We get a deflection of 25 or 0.252 inches. So a little over a quarter. Okay, so this brings us to our final weight of 65 pounds. But first, we need to check our instrument. Let's see if it just got stuck. And it did. We're now back at 0. So we will hook up our last and final weight, which is in the form of a wood planer. No, 0. We're good. Okay. So now we're going to pick up the final one. And this will probably...
I shall assist him with this load.
And we will move these out of the way. Okay. And gently set it down. Okay. Gotta get this.
Will you redial the indicator, please?
There we go.
Okay.
Return back to 0.
Let's make sure that this is slid over the back.
Okay, so
Okay.
let your end down. So. Okay, we're on the point. Continue.
Okay.
Okay. There we go. And this has deformed 0.352 inches. Nope, 0.353 inches. So that, let's see if it returns back to 0. Let's see if the error that we see on the dial indicator is due to friction. And it looks like we have a deformation of 4 thousandths of an inch. So we will be able to calculate this at the end and tell if it was an actual deformation or a error in the measuring instrument.
My name is Braden Shepard.
I'm Levi Glass, and I'm a sophomore here.
I'm Austin Long, kind of like a junior or something.
I'm Pierce Fitzgerald.
And I'm Justin Shepard.
Yeah.
We just do
Red.
it like it's
We're
I
live.
read this right, Mark.
Yeah.
It sucks.
actual thought process. That's what we're recording right here, which could be scary.
Yes.
Might need to be bigger than that. Because he's kind of far away with that camera. He can tell you in the viewfinder.
No, cameras have these wonderful zoom features.
Yeah, he does.
Magnification.
But even then, like, Fred only
You just
zoomed in
see
that
the
far.
board cells.
Okay.
He's only got like a 20 megapixels on.
I don't even know how many pixels this thing is.
So then the
It's a lot. Yeah, you're good.
Your beam's floating in space.
so the
A few inches later.
You're gonna write all your
Yeah.
given values over there?
it's gonna, well, I mean, our unit is it's 10
Plastic modulus.
10? I thought it was 15.
10 at a time.
That's steel.
This way.
No, I thought steel was
10,
10.
No, 10.
X 10 to the E.
6.
Yeah.
For
They make steel's 30.
And it was Pascal's, right?
No, it's PSI.
PSI, yeah, PSI.
You're mixing your units up.
Is pressures?
That's how rockets
It's
blow
the
up.
same thing.
He's under too much pressure, guys.
And then how long was our length?
18.375.
Are you gonna write that down, or are you just gonna do a dimension on the figure?
18.375 feet.
And
I had a solid bar that was 18 feet.
Yeah, I thought about that after a second.
I wish I had one.
There's no podium, does it?
What was
This
our
is-
moment of inertia?
That's how good he is.
yeah,
He doesn't
so-
need one.
IX equals, what was the?
This is for a circle, right?
Inches to the fourth.
E18, which is, it's gonna be the size of the square, which is 1.
pH cube over 3.
Oh, you use the square bar?
No, this one's
It's square? Oh, okay.
Oh, that was a circular bar.
No.
So it'd just be
Well,
b to the
something-
fourth over
yeah.
something?
Yeah, it's we have the fourth over 12. So for
Oh,
us,
it's
it's gonna
square.
be 1.0075.
Isn't it BH? Base
No,
times height.
because it's,
It's
the
a
base is
square.
the same, so you just, take
So
the
it's a
base to the fourth.
Ah,
You
I
could
that's
do
a fun
BH.
test then.
Yeah, you could do
You
BH,
did the
you'd be
same
able to do the
thing.
same thing.
Okay, good.
It'd take long.
So I say, man, I really messed up on that test.
Calculating that.
Hey, all squares are rectangles, but not all rectangles are squares. So rectangles aren't squares.
So writing that out to, how many decimal points is that?
4.
4. 0.0859 rounded.
0.085 inches to the fourth.
Negatives.
So negative 65.
Yeah, that's the part
Oh,
one.
we haven't started yet?
Come on, cameraman.
It's been rolling the entire time.
Yeah, that's what I'm saying.
Oh, you're just gonna put all
Oh, okay,
this.
yeah, just go.
Capture all this.
That's what I was trying to
goodness.
do. That's
My
running. I'm like, his editing is gonna be like 5 hours.
Yeah, bro. Jeez.
I gotta make you
Are
do
you really rolling the
something.
entire thing?
Oh,
Okay, hopefully I'm not swearing too much.
Yeah, me too.
I wasn't paying attention, I thought we weren't rolling.
Oh, shit. No, so that's how you get all the good stuff.
That is gonna be a lot of cutting.
We had a couple of those during the experiment. We're like, well, the dial doesn't go back to 0. That's a problem.
Well, you also need to introduce yourself too. We're already rolling soon.
Pierce Fitzgerald.
We'll do that afterwards.